The Tarzan question is kind of a weird question. Sometimes bothers people. I stole it off a contest I saw once. There was a whole lot of words in it in this contest. There was a tiger chasing Tarzan. You had to do the math to see if he could climb up high enough up his vine so the tiger couldn't reach him or something weird like that. I like it because it kind of brings back into Newton's third law and reaction forces. Think about reaction forces and Newton's third law. For Tarzan to climb up a vine, he has to pull down on the vine. When he pulls down on the vine reacts and pulls up on him. So call it what you want. We could call it an F applied or an FR for the reaction force. But by pulling down on the vine actually pulls up on Tarzan. That's what makes him go up. Kind of like at the rocket question, we can't forget about gravity. Gravity's pulling him down, and eventually we'll sub in an mg for gravity. How he accelerates depends on how big the reaction force is compared to gravity. This Newton's third law thing says the reaction force is always equal to the action force, but all the reading I asked you to do the other week, there's a limit to how big the reaction force can be. In the question I made up here, the reaction force can be as big as 800. Tarzan may be crazy strong, but if he pulls the vine harder than 800, it's going to break. So he can only pull it as much as 800, which means the vine's going to react and pull on him with a force of 800. Now it kind of looks like the rocket question. F net equals ma. He's accelerating up, so we're going to make upward the positive direction. Gravity, therefore, is negative. That's equal to ma. One more little line. The reaction force minus mg equals ma. We know the reaction force was 800. That's the biggest force the vine can put on him before it breaks. The mass I made up for him was 65, so we're going to subtract 65 times 9.8, and that's equal to 65 times A. You can flip-flop things around and do the math, but I get nice, almost a clean number, almost a perfect 2.5. If we carry an extra decimal, 2.51 meters per second squared. You do the algebra on that, see if you disagree. And then for fun, I added a second part to this one. We now know that the fastest he can accelerate up the vine is 2.51 meters per second squared. The question wants to know how much time it would take him to travel a distance of 4 meters. So this is going to connect back to that kinematic stuff. We now know that he's accelerating at 2.51 meters per second squared. He's going to climb up the vine a distance of 4 meters, and we're curious about how many seconds it takes. The missing number in kinematics, there's always 3 numbers and a question mark. We're going to assume he starts from rest. So he's standing on the ground, starts pulling himself up the vine. In this case, we don't care about V2, so the equation that matches best is that 1/2 AT squared equation. We're solving for t, but it's not as bad as it looks. Because of the v1 of 0, this whole first term drops to 0, so we don't have to use a quadratic equation. It's 4 equals 1/2 of our 2.51 multiplied by t squared. Algebra on that one, take your 4 and multiply by 2 to clear out the half, divide that new number by 2.51 to clear that out, then you have to square root the whole thing. After square rooting, I'm getting an answer of 1.8.